Hello and welcome to Module 2, Introduction to Data Collection Instruments and Database Design. This module is pretty broad, so I've divided the lectures into two parts. The first part is going to deal with data collection instruments, which we also call case report forms and their design. And the second lecture will deal with database design. In this part of the lecture, we're going to discuss what a data collection instrument is, some of the common DCIs or case report forms that are used, some of the more common fields you're going to find on these forms, and then we'll start to discuss CRFs and database design issues and talk about the standards that we have to think about or abide by while we are designing DCIs. And we'll have some assignments. So what is a data collection instrument? Well, first of all, I want you to be familiar with the term data collection instrument as well as the term case report or case record form. A lot of times you'll hear these used interchangeably, but essentially these are ways to collect data. In order for data to be useful for analysis, it needs to be collected consistently and in a format that can be quantified. Data collection instruments are simply the tools we use to collect required data in a specific format. For this lecture, we'll focus on the most common data collection instruments, those that are in paper and electronic case report form. Case report forms, or CRFs, are designed specifically to capture the data required by the protocol. Both the paper CRFs and the or electronic CRFs perform the same basic functions. They guide the investigator through the process of collecting the data generated for the trial. They identify what data is required, when it must be collected, and the format it should be collected in. But it's important to remember there are many other ways we can collect clinical data. For example, we might collect patient diary data using interactive voice response systems, or IVRS systems. We might also collect laboratory data or Holter monitoring via data sets that are sent from a central laboratory. Prashka provides an excellent description of several common non-CRF data collection instruments, such as questionnaires, diagrams, and analog scales. This will be part of your assigned reading. Your assignment for this module also includes exploring the websites for several vendors who manage non-CRF data, such as LabCorp. These are groups that you're going to come across when you're out working in the industry. I've mentioned paper and e-CRF several times now. Let's take a few minutes and talk about the differences between the two, as well as their similarities. For many years, clinical trial data was always collected using paper CRFs. Essentially, these were just printed copies of the CRF that were compiled into CRF booklets and distributed to each clinical site. The site staff would record the subject data onto source documents such as patient charts. Then they would transcribe that data onto the paper case report form. The completed CRF would be shipped to a central data management group, and the data management group would then document the receipt of each CRF page and enter the data into the project database. Many studies now utilize electronic data capture, or EDC systems, that are at the site, and these have essentially replaced the paper CRF with an e-CRF. The e-CRF is essentially just a data entry screen. Site staff enter data into an EDC system via that entry screen. Some sponsors still generate a paper version of the e-CRF that's used as a source document or guide. Other sponsors allow direct entry of the data into the EDC system, and others allow the site to transcribe from the subject's health records. We're going to be using a kind of a combined version of this when we work in REDCap. We'll have printed off hard copies of the eCRF, and we'll be using those as our source documents so you can get a feel for what that looks like. The most common CRF forms. Almost every clinical trial is going to be collecting demography, medical history, vital signs, key variables needed to evaluate the efficacy and safety outcomes, concomitant medications, concomitant diseases, adverse events, medication or dosing data, and study termination data. Demography, medical history, vital signs, physical exam, con meds, and con diseases are often part of the baseline data that is collected to establish the subject's starting condition prior to treatment. In some cases, this data is also used to determine whether the patient meets the inclusion and exclusion criteria for the protocol. Vital signs, physical exam, con med, and con disease data may also be collected throughout the study, so it can be compared with the baseline for possible safety concerns or changes. The key variables for safety and efficacy outcomes will be determined by the protocol and the analysis plan. Adverse event and dosing data should be collected at each visit to review for safety and protocol compliance. The study termination data tells us when and how the patient ended their participation in the trial and whether their data can be considered to reflect compliance with the protocol or simply an intent to treat. The University of Wisconsin has a really nice set of CRF templates. One of your assignments is to explore these and see examples of the basic forms and fields, because you'll see these in almost every study you work on. Here's an example of one of the CRF templates from the University of Wisconsin. They really are excellent examples. They're very complete, and most of them utilize a set of standards for field naming called the C- standards. We'll talk about these later in the lecture. In general, these forms make a great reference if you need to create your own CRFs or if you simply want to see examples of common CRFs. Developed a set of principles for good CRF design. So over the years, various organizations have learned that when you are designing or if you are evaluating a case report form to see if it's a good one, you need to keep in mind that the primary goal is to collect all the data required by the protocol in such a way that it can be analyzed according to the protocol and the statistical analysis plan. Collect what you need to collect, resist the impulse to collect unneeded data, and remember, collecting and validating data is time-consuming and expensive. If the data is not going to support your analysis plan, do not collect it. But how do we know what data is required? What do we need to collect? Well, you read the protocol and you review the analysis plan. Specifically, we look at a visit or assessment matrix that tells us what tests are done when. That lets us determine what assessments need to be done and how many times we need to collect them. We also can review the key or critical variables that will be evaluated for primary and secondary outcome measures. Again, this will all be outlined in the protocol and or the analysis plan. And finally, don't forget to collect basic demography and baseline data, as we discussed in the earlier slides. This might not be defined in the protocol, but you know that you need to collect it anyway. It's a sort of a given. Let's talk a little further about the concept of key variables. Key variables are essentially the variables or data that you are going to be using to prove or evaluate your product's safety and efficacy. They have to be present and they have to be correct in order for you to get a valid analysis of what you are claiming this drug can do and what it actually does. Where do you find the key variables? Well, the protocol and the analysis plan will define the primary and secondary efficacy outcome measures. And you can see I have a little example up here that you can take a look at, and we'll talk about this further on in the course when we are developing our own project-specific plans. The safety variables that are key include adverse event data, and that can also be taken from the laboratory or other diagnostic values. In addition, There's data that we always can consider key, such as demography, when the patient started and stopped their participation in the trial, when they stopped and started the study drug, and if they had serious adverse events, for example, if they died or developed a cancer condition. We design the case report form to ensure we collect all these variables and that we do so in a format that can be analyzed. A quick way to identify the key variables is to scan the protocol synopsis and that associated visit scheduler matrix. Here's a nice example of a visit or assessment matrix. Remember, these can also be referred to as visit schedules. You can see here that each subject is expected to have a screening visit, a baseline visit, and 2 monthly visits. The assessments that should be performed at each visit are identified with an X. Some case report form data are not part of the routine assessment, but have to be completed in case of an early withdrawal, a death, a protocol violation, or a serious adverse event. I'd like to take a second here too and talk about the difference between a screening visit and a baseline visit. Screening visits essentially allow you to talk with a potential patient and determine if they meet the inclusion and exclusion criteria. If they do, you continue on and enroll them in the baseline visit. If they do not, you record the fact that you met with them and why they failed the criteria and keep that for your trial documentation. So we've discussed the fact that the primary goal of CRF design is to ensure we collect the required data in a usable format. What else do we need to consider? Well, we need to talk about ways to reduce errors in the data and to facilitate efficient collection of the data. Years and years of data management, trial and error have shown that we want to build the case report forms using a consistent format. We want to avoid the use of free text, avoid collecting duplicate data. We want to reduce the incidence of missing and or ambiguous data. And we want to determine the best use of a per visit versus a running log form. But what do all these terms mean? Well, let's take a look at some examples. Using a consistent format for collecting similar or identical information will speed up data collection and reduce errors. But what do we mean by a consistent format? Well, essentially this means using the same format, field structure, and field naming conventions when collecting similar data. A great example will be dates. Dates can be collected in several different formats. You can collect them as year, month, day, month, year, or month, day, year. You need to pick one format and use it for all the dates you collect. This will reduce the possibility that month and day will be interchanged during data entry. You can reduce entry errors this way, and you'll increase the speed with which the site can enter the data. What does avoid free text mean? Well, free text refers to fields that allow entry of unstructured comments. In the example here, the general appearance within normal limits section has 2 fields. The first is a yes/no checkbox. That field only allows you to enter one of 2 possible responses, and it controls the format of that response. The second field, general appearance not within normal limits, is what we call a free text field. The entry operator can enter alphanumeric characters, numbers, or symbols. There's usually a limit on the number of characters the field can hold, but other than that, they can enter whatever they want. This is a great way to let the site include clinical information that describes the patient's condition. So free text sounds great because it allows more information, but remember that information has limited use if you can't analyze it. And free text or comment text cannot be quantified or analyzed. In order to gain value from free text, you have to have a person or a human review it, try to identify the useful information in it. In many cases, it's going to be assigned a numeric code then, which can be quantified and analyzed. We'll discuss coding data later in the semester. Free text is time-consuming to enter, and it's difficult to verify. It takes longer to enter 200 characters of descriptive text than it does to click on a yes or no checkbox. And if you want to verify that that text was entered accurately, you have to decide to either visually verify it, which means a second entry operator views the text and says, yep, it's right, or no, there's an error. Or you have to have a second entry operator try to exactly replicate the keystrokes used to enter the text the first time. Both ways are difficult and slow, so avoid free text unless it's truly going to add value to your data and you have no other way to get the information. We want to avoid collecting duplicate data. I have two examples here. The demography ECRF asks that you enter both the date of birth and the subject's age. Down below, the drug accountability ECRF asks that you enter the number of pills dispensed, the number of pills taken, and then the number of pills missed. In each of these cases, we're setting up the potential for human error, both in recording the original data on the source document and when transcribing that data into the ECRF. The site staff might miscalculate the age or the number of missed doses. The entry operator might enter the wrong number in either field. Human error will result in the entry of responses that don't match. You'll then be obligated to identify and resolve any discrepancies between the responses. This is time-consuming, and it doesn't improve the overall quality of the data. A better approach is to collect that key data and then utilize programs to calculate or derive the secondary value. For example, it's easy to write a program that will consistently calculate the patient's age based on their date of birth, or consistently calculate the number of missed doses by subtracting those taken from those dispensed. Study coordinators have a difficult job. They often work on multiple protocols, and so they are dealing with many different case report forms. It's easy to forget to complete all or some of a form or provide conflicting or ambiguous responses. These issues are going to be identified during data review, and we'll have to resolve them. So we want to design case report forms that'll prompt the study coordinator to complete the form and perform key tasks. And we also want to design it to help us understand what did or did not happen at the patient's visit. For example, you might receive a blank laboratory visit CRF. You don't know where the lab test performed? If so, where is the data? Or was the patient out of town that week and therefore no lab work was done at all? Adding a checkbox for not done is a simple way to document what happened. In the Visit 1 eCRF, we prompt the site to tell us whether or not the patient came in for the visit. The text in red indicates that the site must complete this field. They cannot skip it. This is typically referred to as a required response format. In the Breakthrough Bleeding CRF, we also use the required response format to force the site to tell us if the patient had an adverse event or concomitant medications. We can also add prompting text in blue, which reminds the site to complete the AE and ConMed forms if necessary. During a visit to the clinical site, like a blood pressure reading. Typically, a unique CRF is created for each visit that data is collected at. So you might have a baseline laboratory visit, a Visit 1 laboratory check, a Visit 2 laboratory check, etc. Other data is created or occurs across visits or dates, like an adverse event or the concomitant medications a patient is taking. If you collect and enter the AE or ConMed data at each visit, you might end up with the same adverse event duplicated or entered multiple times. At the end of the study, all the AEs would need to be reviewed and the duplicates would need to be merged into a single record. The alternative is to maintain a running record or log in which an AE or ConMed is entered once and updated only when that AE ends or changes. The problem here is that the site may forget to check for new or changed AEs at each visit, so many sponsors choose a dual approach. They create a running log form, but they add an AE yes-no prompt question to each visit. This is a nice example of a ConMed log form. The site can enter the ConMed when they first learn about it, and then ask at each visit if there are changes. Note that there's even a field to indicate that the ConMed is still continuing at the end of the study. So, how do these CRF design principles relate to database design? Well, the purpose of the CRF is to collect all required data in a manner that supports analysis. The purpose of the database is to store that data accurately and in a way that allows it to be retrieved for analysis. In our next lecture, Part 2, we'll look at how we take the case report form and use it to create the database. Before moving on to the Part 2 lecture, I recommend you read the textbook assignments, CRF Design Considerations on page 9 to 22, and the excellent article on Effective Design Principles for Case Report Forms. Also, take a look at the web pages for groups that produce non-CRF data, and then move into the Part 2 lecture module and the assignments that come with that. Have fun!